Hi, so my name's Nic Jackson and I work for Hashicorp. And what I want to do is to try and help you get the most out of your Hatch scholarships. And one of the things that we can help with that is to look at sort of the application and practices of modern DevOps. So in these next few short lectures and seminars, webinars, whatever you want to call them, we're going to be looking at just that. So in the first one, we're going to look at immutable infrastructure. We're going to have a quick look at why it's important to you as an organization. Whether you're a large or a small startup, it doesn't matter. Immutable infrastructure and the approach is really, really important. And we're going to look at how we can use Terraform with DigitalOcean so we can get a little bit better with the sort of the consistency and the reproducibility of deploying your infrastructure and creating your environment. So without any more delay, let's get going. So I've got a few short slides to run through you with, but I am going to be looking at some code samples as well. But let's dive into those slides. So before we look at sort of concepts like infrastructure as code, we need to understand what the problem with modern systems are. And predominantly that problem is complexity. So you kind of start off with a lot of very simple systems. So a lot of organizations are just going to start off with platform as a service. But the kind of, as you grow and as you mature as an organization, you find that you sort of start to fast default to infrastructure as a service. You know, like PaaS is amazing, but it just doesn't necessarily scale with application complexity. I mean, consider this as an example. So you start off with a simple web application, and this is fine for a while. So something like platform as a service works really well in this instance. But then you add another sort of web application. So you might start to scale that. Again, we're generally okay with sort of a platform as a service, but you soon start to find that, well, I need to add a load balancer. I need to start making my application highly available. And then you sort of move one step further and you think, well, I really need to be sort of thinking about my security and need to applying some sort of firewall rules. Oh, then I need DNS because I want to be able to manage the DNS settings for my load balancer and access into my systems. So already we've kind of grown quite considerably in terms of the number of components and the complexity of those components. But it doesn't stop there. Because the next thing you start to do is decomposing your application. As the application grows, you start to look at ways to manage the complexity. And one such way of managing complexity is through microservice architecture. So instead of adding those extra elements to our sort of web front ends, we start to break things down. We add an API. This gives us easy capability to do things like add mobile front ends. But then that keeps going. I mean, it never stops. So you sort of add more sort of elements. We add some sort of back-end microservices. So I've got a checkout service now, and that's encapsulating specifically the logic around my checkout. And I add an email service because, well, you know, I kind of want to be able to, again, separate out that logic. I want to be able to deploy these services in individual cadences. Kind of classic microservice problem solving. And the email service needs storage, so I need to add some storage capabilities. Oh, but then I need to add another firewall because, you know, I need to be managing network segmentation between my front end and my sort of back end services. So it all starts to add up. But it doesn't stop there because you generally start thinking, well, hey, I'm successful now. I'm operating in a single region, but I want multi-regional availability. I want to be able to take advantage of low latencies between various different areas of the world that I'm operating. So you've got your first region, you add your second, and then you start to think, well, my development is starting to become more complicated, my system's more complicated. I really need to have a development environment which is mirroring both my production areas. And then there's testing. So again, we want a testing environment which mirrors both development and our production environments, and potentially another testing environment, and another testing environment, and another environment, and another environment. you know, it just doesn't stop. And the key concept is that building multiple environments manually just does not scale. You look at clicking through the various different interface elements to upload and create the droplets and the firewalls and the load balancers in DigitalOcean, and it's fine for a small scale system, but what you don't have is the sort of the consistency and the ability to exactly reproduce that across multiple of your environments. And this reproducibility and this consistency is essential to system stability. So you've got to think about the way that you're testing your applications. And a real sort of valid test on an application is one which, when you can push that into production, you can be absolutely confident that nothing is going to go wrong. And to have that confidence, you've got to be ensuring that the production and the test environments are the same, that there's no differences between versions of application software. And this could be kind of low-level sort of operating stuff. It could be versions of OpenSSL. It could be, you know, particular drivers that you have installed for your data stores. When you go through this manual provisioning, that's a tiresome process. It means that your environments can fast come out of date, and then that destroys the consistency and it reduces your test efficacy. So infrastructure as a code steps in and tries to help this. So Terraform is a product by Hashicorp, and it's an open source product. And what Terraform does is Terraform allows you to define your application infrastructure as code. It follows this 3-step approach. So you write your infrastructure declarations, you then run a plan, and you run an apply. So writing Terraform code, well, it's a way of sort of creating this declarative configuration. It's a way of defining your infrastructure as code, which means that you've got this consistency. You can share the knowledge around creating this infrastructure, and because it can be stored in version control, it can be collaborated on by your teams. We have a kind of a key concept, which is if you can codify it, you can automate it. Terraform configuration, it looks like this, and it's pretty straightforward, and the example we're going to go through today will get you up and running in no time. But ultimately, it's defined in a language called HCL, or the Hashicorp configuration language. We went down the lines of HCL because we wanted certain programmatic elements within the language which weren't present in the likes of YAML or JSON. But also we found that whilst JSON was incredibly good for a machine to understand, it didn't create the best readable code. And this is the key thing, that we want to be able to create our infrastructure code so it's self-documenting. So Terraform plan is the second step. So we've written our infrastructure code, and then we get into the Terraform plan concept. And what plan does is it looks at the code that you've written, and it understands what needs to be done in order to create those changes in the cloud. So it can understand that those definitions that you wrote will result in an infrastructure element in DigitalOcean. And the plan can kind of show you these changes, what will happen before you actually go ahead and action them. In addition to this, the plan understands dependencies. You don't need to worry that you've got to create a droplet before a load balancer or SSH keys before a droplet. Terraform understands that through the way that you're mapping the dependencies inside of your declaration. We run a plan using the Terraform plan command, and Terraform's going to look at what your infrastructure is, and it's going to go and determine what the changes need to be made. And you get that in a really clear, simple to understand format. So you've got the ability to make a decision on whether you want to action that plan or whether there may be some mistakes in there. Then you get on to the apply step. So the apply step is taking that plan and it's actioning those changes. It's creating the infrastructure inside of DigitalOcean. And the ability of this plan and apply step is that you've got It's a very simple way of provisioning identical environments. So you've got the ability to create an identical production environment, an identical staging environment. You can kind of effortlessly combine high-level system providers. You may be using Fastly or something like that for your CDN. You might use DNS Simple for DNS management. Terraform gives you the ability of having a single workflow. You can manage your DigitalOcean infrastructure around your Fastly CDN all from a single set of configuration. When we run an apply, we're going to see something like this. And we're going to see Terraform as it's creating those resources inside of DigitalOcean. So let's dive in. Let's have a sort of a quick look at what Terraform looks like, and let's see how we can build up this infrastructure. So what I'm going to do is I'm just going to cut and paste this from the docs because, hey, I want to try and show you that you don't necessarily need any real sort of knowledge or skills to use these tools. So I don't have any droplets that I've created with Terraform at the moment. I've just got my remote jump box in DigitalOcean. So I'm going to go and create a droplet. So let's take a look at that. So if we look at the documentation on Terraform, you'll see that we have all of these resources and all of these data sources. So a resource is an element of infrastructure inside of DigitalOcean. So you can see I can create volumes and volume attachments. I can create snapshots. I can create DNS records, firewalls, IP addresses, load balancers, and the provider's under sort of active development. So once we get things like the Kubernetes service, which is coming to sort of public release, you'll be able to create Kubernetes services as well. But for now, we're just going to create this DigitalOcean droplet. So let me cut and paste this. I'm going to quickly copy that. And I'm going to move over to my code window. So I'm just editing normal files, just text files. So I'm going to add a file, and Terraform will attempt to read any file which ends in .tf. So I'm going to create terraform.tf in my working folder. And then I add my resource to that. So that's ultimately all I need to do. This is like the absolute bare minimum. So let me explain what's kind of going on here. So in terms of Terraform, this block here that you see, we call this a stanza. And the first word, resource, this is the type of stanza. So we have a resource stanza. And a resource stanza is something which will result in a piece of infrastructure inside of DigitalOcean. We then have the resource type. And each provider is going to prefix this resource type. So as you can see, we're going to create a DigitalOcean. So that's the DigitalOcean provider. And we're going to create a droplet. This last parameter, web, well, this is going to be the name. It's not going to be the name that's created inside of DigitalOcean. It's going to be the name that I'm going to use to refer to it from Terraform. I can specify a number of different options. As kind of a bare minimum, I want to set the image, and I'm going to create a Ubuntu 18.04. This is the name that it will be created inside of DigitalOcean. I'm going to set the region. I'm going to use NYC3, and then I can specify the size. So I'm just going to create a single virtual CPU machine with 1 GB of RAM. If we look back here, there's a whole bunch of other options that I can create. So I can do things like the sort of configure whether I want backups, whether I want monitoring enabled, to enable IPv6, private networking, SSH keys. So we should probably add an SSH key, and we'll have a look at how we do that as well. Tags, user data, volumes, kind of all sorts of things. These are our inputs, our arguments. The attributes, these are all of the things that we can get out of it, and we'll see how we can use these attributes to kind of start linking elements of our Terraform code together. So let's add another resource, and let's add that SSH key. So again, SSH key, I'm just going to copy and paste from the documentation. Really, really easy. Terraform example, let's call this, that's fine. And let's specify the location of our public key. So I believe I have a public key on my disk here, which is in my home folder, SSH server rsa.pub. So what am I doing here? That's kind of strange, right? I mean, public key, if you look at the documentation, it says the public key, if this is a file, it can be read using the interpolation function. And this is interpolation. So we have this dollar, this curly bracket, and then we have this word file. So interpolation is Terraform's way of creating dynamic configuration, and this will be replaced at runtime. So when I run my plan or my apply, what Terraform is going to do is it's going to use the file interpolation function. It's going to read the location of a file, in this instance server RSA from my home folder, and it's going to return that as a string and set that as my public key value. Now in terms of the resource, how do I add that to my resource? Well, if you kind of recall from our documentation, we have an argument called SSH keys. And SSH keys is optional, and it says a list of SSH IDs or fingerprints. To retrieve this information, use curl with DigitalOcean API. Well, as it happens, I can also use a data source, or I can just directly reference it using interpolation. So let's have a look at that. SSH keys. I'm just checking I got that right. And I'm going to use a list. So I'm using the square bracket, and I'm going to get the interpolated value. So it's DigitalOcean SSH key dot default .id. So I've got that ability to reference other elements in my Terraform configuration using this interpolation syntax. What interpolation also does is it tells Terraform that in terms of the order of build, that before I can reference the SSH key ID, well, the resource has to exist. So Terraform knows that it has to go ahead, create the DigitalOcean SSH key inside of my DigitalOcean account before it goes ahead and creates the droplet. There's one last thing that we do need to add, and that's the provider. Let's just have a quick look at that in the documentation. So in terms of the DigitalOcean provider, and the provider is kind of the API configuration element of a Terraform. So we're going to generally set things here like the token. So this is going to be my DigitalOcean API token, and I can set this as a variable, and we'll look at variables in just a bit. Or what I can do, and which I think is a much better approach, is to set the environment variable in my shell environment, and Terraform's automatically going to pick that up. Now I've already got this token set because I don't want to share my API token with the world, and nor should you. So you should think about that, and whenever you're creating your Terraform configuration, don't do things like pasting the token in and then committing stuff to GitHub. Keep it secret and use things like the environment variables capabilities in order to keep it separate from your configuration code. All right. So we've got our DigitalOcean provider, we've got our SSH key resource, and our droplet resource. Let's run a Terraform plan. Now, before I run my Terraform plan, I do need to do one thing first. And that's to run a Terraform init. And what Terraform init does is it downloads the provider plugins. So the Terraform core application is separate from the Terraform provider binaries. And that's so that DigitalOcean can version the provider at a different cadence to the way that Hashicorp are versioning Terraform. It just means you don't have to wait around forever for updates. So let's clear that and let's run our plan. All right, that was quick. So if we have a look at this, the first thing you'll note is that plan is telling us that it's going to add 2 resources. And we can scroll back up through this plan and we can have a look. So we can see that we're going to create a DigitalOcean droplet called web, because that's highlighted in green. We can see that the attribute backups, we're not switching, they're switched off. We're setting the image. We've got IPv6 switched off, monitoring off. We can see the name, the region, and the size. We can also see that we're going to create this SSH key. And if you remember from when I was talking about this runtime interpolation, that Terraform is going to read that file, because I'm using the file interpolation function, you can see that the public key is there in my plan. So the next thing to do is run and apply. So again, apply is gonna sort of just show me that plan, but it's now going ahead and it's going to be creating those resources. So let's flip over to that droplet view inside of DigitalOcean. And you can see there, my resource for my web 1 is already being created. And that takes about 20 seconds because DigitalOcean is pretty darn quick at creating resources, but we're just going to wait for that. Well, we're just going to wait for that to finish. As I said that, it finished. But you can see, apply complete, 2 resources added. Back over in my console here, you can see here's my web 1 instance and here's my IP address. Now, I can quickly SSH into that machine. So if I do whoops, let me just clear my terminal. SSH. And I'm going to do root at IP address. I'm going to specify my key. So this is the private part of my key. Yes, connect. And there you can see I'm now SSH'd into that terminal. So within about 30 seconds, I've written the Terraform code to create my infrastructure, and I've managed to log into it. So that really is the absolute basics. It's the sort of the first step on your journey. Just before we go, and we're going to look at this more in depth in the sort of the following videos, but I just want to show you some more quick tips and tricks around what we can do with Terraform. So the first thing is we've got a lot of hard-coded values here. So I've hard-coded the region and the name and all of these sizes. I've got a capability to make that dynamic, and I can use a feature of Terraform called a variable. So I'm going to create a variable, and let's call this region. So I'm going to set a default value, because this is an optional step, but I want to set a same default. Set that to New York 3. And then rather than have this hard-coded value down here, what I can do is I can replace that using interpolation and a variable substitution. So I use var, which is the keyword to access a variable. Region, close my interpolation, and save that. So if I run a Terraform plan again, Terraform's telling me that there's no changes to be made. So Terraform understands that even though I've changed my configuration, the resource that I previously created was in New York City 3, so it doesn't have to make any changes. So what if I did change that region? What would happen in terms of Terraform? Well, we can see that. So I'm just going to run apply again. I'm going to specify a variable as an override. I'm going to set the region. I'm going to set it to lun1. So I've got that variable defined here, and it has that same default. But Terraform allows me to use things like environment variables, or in this instance, using command line flags to be able to override that. Now you can see here that in this plan, Terraform is telling me that, well, it's going to create a new resource. So it's going to destroy one resource and it's going to add one resource. You can't just move the region of your droplet. You've got to destroy it and you've got to recreate a new one. So Terraform understands that logic and it can manage it for you. So I don't have to manually do it. I can do it completely automatically. Let's run that. Back over here to our console. And Terraform has destroyed the old one. Just wait for a refresh. My internet's probably running slow. You can see I'm creating the new one. This is now in London 1 region. Again, 25 seconds and that'll be complete. Awkward pause because it's obviously taking longer this time. There we go. It's all done. So we've destroyed one, we've added a new resource. And you can see here again the IP address. But wouldn't it be nice if Terraform would show me that IP address after it's run? Well, you know, we can do that too. We've already looked at variables, which are the inputs, but we can also write outputs. Again, very simple. Output, keyword, IP address. I'm going to specify the value. I'm using interpolation syntax, and in exactly the same way as I'd sort of took an interpolated attribute from the DigitalOcean SSH Key resource in my droplet, I can do the same thing with my output. So I'm going to do DigitalOcean droplet.web, and we're going to get the parameter, which is, I think it's IP address. Better quickly just flip over to the docs. And we go to our droplet, down to our attributes, IPv4 address. IPv4 address, close that. And this time I don't need to run or a plan or apply. I've just changed an output, so I can just run a refresh. And you can see there, I've got my IP address in my output. And that gives me a nice, easy way to use it. So if I want to SSH into that machine, I'm just going to do SSH, specify my key. And rather than sort of typing in the IP address, I can use the Terraform output command in a subshell, which is just going to return me the IP address. So root at Terraform output, IP address, Terraform. Oh, good God. Sorry. Can't type. Mr. Dollar. There we go. So I'm connected. And then I've got that. All right. I'm pretty much done. There's one last thing I want to sort of mention. So I have resources running in DigitalOcean. This is costing me money. With Terraform, in the same way that I can easily create those resources and I can do so consistently, I can also clean up after myself. So I can use the Terraform destroy command. And Terraform destroy is going to create any of the resources that I have defined in my configuration. And it's telling me that it's going to perform the following actions. It's going to destroy the droplet, and it's going to destroy my SSH key. So I'm going to say yes. Terraform's going to again be contacting the DigitalOcean API. It's going to go through and it's going to destroy all of those things. And it's done. So we've just cleaned up ourselves. You wouldn't necessarily want to be destroying your production environment, but like if you think back to all of those test environments and dev environments, you know, it gives me a really simple way. Within minutes, I can have created complicated infrastructure, and in minutes I can have destroyed it. So it allows me to keep my cost burn for my non-essential infrastructure at an absolute bare minimum, as well as giving me the opportunity that I can duplicate that production infrastructure whenever I need to. It gives me that consistency and that reliability. Thank you so much for listening today. And you can hit me up in the DigitalOcean Hatch Slack. I'm more than happy to answer any questions in there. And also, if you want to find me on the web, you can find me at Sheriff Jackson on Twitter, and also feel free to email me at nic@hashicorp.com. I hope you found this useful. We're going to be building on this over the next few weeks and months. Really just want you to get everything you can out of the program. Hatch is a wonderful thing. It's a great opportunity, and we want to do everything we can to help you take advantage of it. Thanks so much, and see you next time.